Hi everyone, welcome to the next lecture. In today's lesson, we will look at how we can convert factors to other data types. So in the previous lesson, we ended with the sex data object, which is currently a factor with two levels. So if we wanted to convert this back to character data, we can use the as.character function. And then in the function, we specify the name of the object that we want to convert. In this case, it is the sex_data object. So once again, if you run a command like that, the output is only printed to the console. If you want to save this, you would need to assign it to a new object. To convert factors to numbers is a little more tricky. First, you would need to convert the factors to characters and then to numbers. So let's do an example. Let's create a new object called year_FCT for factor, alt- for the assignment operator, and then we use the factor function that we used previously to create a new factor. And remember, when you specify more than one element, we need to use the concatenate function. So we type C and the brackets, and inside let's use 1990 as the first year, 1983, 1977, 1998, and 1990. So let's run that command, and you will see that the factor has been added to the environment, and this factor has 4 levels. So even though it contains 5 elements, 5 different values, 2 of them actually repeated the 1990, and that is why you only have 4 labels. It's only 4 unique year values. So your instinct might be to use the as.numeric function to directly convert this new factor to numeric data. But if we run this, oh, I made a typo. So as you can see, object year fact not found. So I accidentally added an A there. So let's try that again. So as you can see, when you try to convert a factor to a numeric data type by using the as.numeric function, you actually don't get the elements, but rather the integers for those specific elements. So I want to go back to the presentation where I showed you this image of the handbag previously. Remember that factors are actually stored as integers in R, not with the actual character data. So in this case, it sorted the values chronologically, and it assigned an integer value to each level. So now it is returning the integer value of each level instead of returning the actual values. So one way of fixing this is to do a nested function. This means a function within a function. So while we have the as.numeric function, instead of just specifying the factor, the year_FCT, we nest it with the as.character function. And only inside this function, we specify the name of our object. So this works like any other mathematical operation. It will first evaluate the inside of this bracket. So it will first take this factor, year_FCT, and convert the elements to character data. Even though we see numbers, it's going to convert it to character data. And then it will take this result of character data and convert that to numbers. So let's run this command. And now you can see that we get the actual elements as numbers. So the recommended way is to rather include the levels function. So once again, on the outside, we will use the as.numeric function, but instead of converting the data to characters, we will make use of the levels function that we learned previously. and specify year underscore FCT, which is our factor. And then on the outside of the last closing bracket, we will use the indexing notation. So that is the square brackets, year underscore FCT. So first of all, you will obtain all the factor levels using the levels year FCT notation. Then you will convert these levels to numbers using the as.numeric function. And then you will access the numeric values using the integers of the vector year underscore FCT. Remember, square brackets are for extracting. So this is the recommended way of converting factors to numbers. When your data is stored as a factor, you can also use the plot function to get a quick glance at the number of observations represented by each factor level. Let's do an example. So we will now go back to using the original sex column in the surveys dataset. So you can use the plot function, which is in the graphics package of R, and then specify the column of data that you want to plot. But remember, we previously converted the sex column to a factor. So the plotting will now work because a factor means the data can be categorized and counted. If we try the same command on the species ID column or any other character column, it will not work. You need to convert the data from a character to a factor first. So if we say plot surveys $6, we will get this plot here at the bottom right. I'm just going to adjust my pane here at the bottom so that the plot can display a bit better. So you can see that we have female and male, or F and M, as noted in the data. This is just a basic bar plot, but we will not be making use of this plot function for the future graphs that we'll be making. We will rather make use of the ggplot2 package, which is written especially for visualization. So, however, if we go back to the data, we previously saw that there were also data missing for the sex column, but it's currently not displayed on the plot. So in order to add that, we first need to pull out the data from the sex column. So once again, let's assign this to the object we created previously, sex data. We are just going to overwrite the data that is currently there. Use the assignment operator and then surveys $6 to pull out that column. So let's view the levels to see what we are dealing with. So levels sex underscore data returns only two labels, F and M. So in order to add NA for the empty cells, we will use add NA function. So we need to reassign this to the same object called sex data. So we use the add NA function, and inside we specify the data. So we will take the sex underscore data factor and add NAs to all the empty cells, and then write this data back into the original sex data factor. So let's run this command. And now let's check the levels again. So levels sex underscore data. Now you can see a third level, NA, has been added. You can also use the previous functions we learned to inspect the data. For example, head sex underscore data will show us the first 6 elements in this case, because it's not a data frame. The sex data is a factor, so it will display the data like a factor horizontally. So we can see MM and then 4 NA values. So if you look at the previous output, F, M, and NA, The levels are ordered alphabetically, F, M, and then the empty ones. So in order to pull out this NA for us to rename it, we are going to make use of the square bracket subsetting again that we learned previously. For example, levels sex underscore data. If we do that, we get all three levels. So we want the third position, the third index. So we just add the square brackets that we learned previously and position number 3. So if we do that, we are isolating this level only. And in order to replace something, you can make use of the assignment operator. And we can now specify the word undetermined inside quotes. So if you read this from right to left, it means take this undetermined and replace it everywhere where this position 3 occurs, which is the NA. So to just make it a bit easier to understand, to the left of the assignment operator is what we want to find, and to the right of the assignment operator is what we want to replace it with. So if we check the levels of sex data now again after renaming, it didn't work. Oh, because I forgot to actually run line 235. So if we run that line first to actually rename the data and check the levels now, it will show us F, M, and undetermined. So if we now plot this data again, sex data, you will see that the plot is updated in the bottom right panel, and it includes the counts for the undetermined entries. So this concludes this lesson for converting factor data, and I want you to please complete challenge 8 and 9. In the next lesson, we will look at how we can format dates.